Good morning. My name is Mike McVeigh, and my company is Paramount Geothermal. And today we're going to talk about the design and installation of a pump and inject geothermal air conditioning and heating system here in Florida. This homeowner originally installed a geothermal system in 1990, and it's a split system with a 5-ton and a 3-ton system with the heat pumps outside, and the air handlers are one in the attic, one in the closet. The initial system had a 3-foot deep horizontal well put in that was much too shallow and it didn't function. Shortly thereafter, he had a second well put in. This one was placed 6 to 7 foot deep, and it's about 1,000 feet long, and it's what's called a slinky loop. And I'll show you a picture of a slinky loop later in the video. This loop worked fairly well for a number of years, but on hot, dry summers, I believe as the sand tended to dry up or the water table dropped enough, it no longer was able to store as much heat as it had originally. So in the hottest of summers, the system would occasionally not function. So this homeowner decided at that point to add a superficial pump and inject well, which he did. That's been running for some years through a heat exchanger. So the system today basically runs the 5-ton unit, operates off the superficial pump and inject, and the 3-ton off the horizontal slinky loop. Both systems are still working, though occasionally the horizontal loop is still not quite adequate. So what we're going to do today is we're going to add a deep well pump and inject system. And that system will go down 100 to 200 feet, pump water out of one well, run it through the heat pumps, and then return it to what is called an injection well. So the water in the aquifer is not changed. We don't waste the water. It's simply borrowed temporarily and then returned back to the aquifer. So let me tell you a little bit of why I'm excited and why I think geothermal matters. We waste enormous amounts of energy in this country, and that has to stop at some point. Geothermal is an opportunity to significantly reduce the energy we use to heat and cool all of our buildings, residences, high-rises, commercial buildings, schools. It reduces the amount of energy it takes to heat and cool those facilities by as much as 60% or more. Also turns out it's a great way to heat swimming pools. It's 75% cheaper than using natural gas. But I see the value of geothermal not only in cost, where there's great opportunities for people to save money, but it also is beneficial to the environment. It burns no fossil fuels, it is renewable, it is available for free in the ground, and I'm very excited about the geothermal industry and the geothermal opportunities. So what we're going to talk about today is a little more detail of what the well designs are, what the equipment designs are, and this homeowner will be, in the next video that we have, will be upgrading his system to add a modern or more current technology integrated heat pumps, replacing his current air handlers and heat pumps with an integrated unit and integrated unit in the attic. So we'll talk about that later. But thank you for your attention, and I hope you enjoy this video. Here we can see the pump and inject well field. In the foreground is the pump well that I'd shown you previously. And then of course in the distance is the inject well, placed about 50 feet away. Fairly simple system. And the inject well basically just has a 2-inch pipe that runs along the yard over to the equipment shed, as we'd shown you before, back in here. You can see the pressure buffer tank for the system there on the left. It's a fiberglass tank. And again, returning to the injection well in the distance, it's a 2-inch drop pipe that goes down 70 feet. The homeowner also has an additional piping for some additional electrical power for future application. Here we show the plumbing coming from the well field and returning to the well field. And here we have a check valve in the line that comes from the pump to maintain pressure in the pump well so that the water doesn't drop back into the well each time. There's a pressure tank. This tank is a little larger than is necessary for this Grundfos system, but it does no harm. In the middle, towards the bottom, that small cylinder is a sediment trap to catch any sand or other debris that might be in the well. And everything basically plumbs from there into the rest of the plumbing system and up to the heat pumps. And from there, of course, the heat pumps have refrigerant connected to an air handler. This is the outside area that has all of the heat pumps and all of the valving. There are also some large tanks that were used for a rooftop solar heating system for hot water. I'll show you the valving as we get closer here. It's very complex in order to preserve the ability to select all of the various wells. Here we have the two white pipes coming up are coming from the pump well and then returning to the injection well. These gauges show both pressure and temperature of the water coming in and going out. You can see the system is currently running at about 50 psi, and the water is coming in at 77 degrees. This very complex piping project up here was again necessitated by the desire to preserve all of the existing pumps, which are shown on this wall. Basically, each loop had a push and a pull pump installed. What we can see going around to the other side of this area is the controller. This is a Grundfos variable frequency control. It varies the speed of the pump to regulate pressure at the pressure you desire. I've selected 50 psi for this system, and with the two flow regulators shown here and here, the large unit is regulated to about 10 psi. It's running, I tested it at 12 gallons per minute, not psi. The 3-ton unit is the other unit, and it runs at about 7 gallons per minute. These are motorized valves that when 24 volts is applied, they slowly open to prevent water hammer in the system. They provide the water to allow the water to flow to the heat pumps when the system calls for heat or air conditioning. These are Taco motorized valves. Here's Steve's working on the heat pumps that are up on this homeowner's deck, the 3-ton and 5-ton units. In order to hook up the pump and inject well, we wanted to preserve the ability to connect the existing horizontal loop that operates the lower 3-ton unit and the superficial well that operates the upstairs unit. So we have a bunch of valving that allows us to either run any one of those wells to the heat pumps as desired by the homeowner. So this is those heat pumps were put in 1990. They're still functioning. They've been covered from the sun a bit, but as you can see, geothermal heat pumps are very reliable and will last 30 years and sometimes more, even though they are outside, unlike air-to-air units that you're familiar with that tend to fail in 5 to 7 years. Another close-up view of the injection well. Sometimes people put large synthetic rocks to cover these to make the landscape more appealing. This is the next door neighbor's conventional air-to-air system. You can see it has 2 units. The unit on the left is only a few years old and is already beginning to rust from the salt sea air. These are good units. I would expect them to last 10 years or more. But again, the geothermal units will last 2 to 3 times as long. Another close-up view of the injection well. Sometimes people put large synthetic rocks to cover these to make the landscape more appealing. I hope you've enjoyed this video. I made some measurements on this system before and after, and what I noted was before the system was operating using the existing outdoor heat pumps and the air handlers in the attic and closet, that the efficiency improved once we added the new pump and inject well system, primarily because the water coming out of the ground is at 75 degrees, as verified on these temperature pressure gauges that I showed you, and that's increasing the efficiency of the heat pump. So this heat pump is now operating about 10% more efficiently. And in fact, I checked the air temperature coming out of the supply vents, and it's about 5 to 7 degrees cooler than it was prior to the installation. The horizontal loop is bringing water into the heat pumps at anywhere from 85 to 90 degrees or even higher at the hottest times of the year. So the constant well temperature at 75 degrees, which will not vary throughout the year, results in a system that has very reliable, predictable, and excellent performance efficiency.